maximum or. So we are giving an array of nums, so inside it is always to be positive integers. So we are giving a zero index integer array nums of less n at a integer k. So in one operation, we can choose an element and multiply it by 2. So for example, if k equal to 1, this means we can choose any number, either 12 or 9, it can multiply by 2. So for example, first of all, we have this 12 and 9, and we can multiply 2 by either one of them. So for example, we can use like 24 and 9, so this means 12 multiplied by 2, it's going to be 24. So another case is that it's going to be 12 and 18. Yeah, but this one, 12 and 18, going to be the maximum of XOR, because 12 and 18, so it's going to be 30, and it's going to be the maximum. So if we are using like 24 and 9, let's just check the result. So 24 and 9, let me just return a random number 0. Yeah, so as we can see, 24 and 9 XOR it is 25, but 12 and 18 it is 30, so it is the maximum. Yeah, so if we are using 12 and 18, so it's going to be 30. So as we can see from here, it is 30. Yeah. So currently we are not sure which number we're going to choose. So for example, if k equal to 1, whether it is a 9 or it is a 12. So this is okay. So in the second example, if k equal to 2, so what are we going to choose? Whether we're going to choose 8 or 1 or 2, or we're going to choose 8 for multiply 2 and 1 multiply 2. But we are going to calculate the maximum number. Let's just check what's going to happen for such case. Yeah. So currently this is the binary number. So here, so for example, we have a 1. So this is another binary number. It can be 0 or 1. And this is another binary number. So if they are always to be the equal length, so for example, in this example 1. Yeah. So in this example, which number we're going to choose to have the maximum number? Yeah. So they have the equal length. So it can be any one of them. For example, it can be 9 or it can be 12, because 9 times 2 is bigger. This 18 and this 18 or 12, it is 30, it is bigger. Yeah. So this means if they are equal, but maybe some of them is shorter. So for example, some of them is shorter. Do we need to consider the shorter ones, or do we need to consider the longer ones? Of course, we're gonna consider the longer ones, because this is the greedy idea. Because if this is a longer one, if we use multiply by 2, it means the binary shift left. So this means this number is going to be 1, and this is going to be a line. It's going to be longer. Yeah. If this is the maximum, what's going to be the next step? Of course, we're going to increase this number because it has already been longer. According to the greedy idea, this is going to be longer and longer and longer. So this means, yeah, if some of them are equal, definitely, if we want to get the maximum result, it must be one of the numbers. It cannot be several numbers multiplied 2 at the same time. It can only be one of the numbers multiplied by 2. This is one case. So another case is that if this number is longer, this is 1 and this is something, and others are shorter, and what are we going to consider? Yeah, we only consider the longest one. It is only this one can become the maximum number. If we use this number multiply 2, it's going to be bigger, bigger, and bigger, and then we're going to use XOR. Yeah. So in this way, it seems the problem becomes easier. It means inside all the numbers, we only need to choose one number. So for example, yeah. So in this example, let's just use the 812. This example. Yeah. If k equal to 2, what's going to happen? So we just need to shift this 8, because this 8 is the longest. For the binary numbers, it has 3 bits. So it's going to be 16 and 32. And this is 1 and this is 2. So the final result is going to be 35. So this is going to be the maximum number. Yeah. So if we understand about it, now we're going to use some idea to solve it easily. So what kind of algorithm can we solve such kind of problem? I mean, we only need to choose one number. Maybe this is 8, next time maybe it is 1, or maybe next time it is 2. Of course, we can use the prefix or suffix sum. But for this problem, we need to use prefix and suffix sum together, because only in this way can we solve the problem easily by just using on time. Yeah. Now let's just use this idea to solve the problem. So we're gonna prepare n gonna be length of the nums. Let's just prepare the prefix and suffix array. So I'm gonna use copy the nums and the nums. Yeah. Now let's just calculate the prefix. So for the prefix, so for I in range from 1 to n, so pre I gonna add gonna all equal. So here we're gonna use all equal pre I minus 1. Yeah. And similarly we can use calculate the suffix. So for I in range n minus 2, minus 1 and minus 1. So this is going to be the suffix XOR. Yeah. So for the suffix XOR, it's going to be similarly like this. So it's going to be suffix I plus 1. Yeah. So now let's just print out the prefix and suffix. Let's just check what is inside. Yeah. Let's just return 0 at the moment. Yeah. Let's just check what happens for this prefix and suffix array. So now, as you can see, our prefix array is 12. For the next one, 12 and 9, it is 13. And if we are going to calculate the suffix, this is 9. For the next one, it is 13 as well. This means our calculation is right. Yeah. But for this problem, we should not calculate. We can calculate it like that. But how can we calculate the final result? So, for example, this is the prefix array, and this is the suffix array. Yeah, they have the they are equal in length. So this is a prefix array. If we are going to calculate some number inside of the nums, so for example, this is a num. Yeah, if we are going to calculate this number, what's going to happen? So it must be something at the left side of the prefix array, and it must be something at the right side of the suffix array. Yeah, so we're going to use this number XOR. This number or this number, and we're gonna use or this number, and this number gonna be shift left k times. Yeah, and this is our number. Yeah, but if we are going to calculate it directly like this, how can we calculate the first number or the second number? Because for the first number it is 12. At the left side there's nothing, so we need to prepare padding. And similarly at the right side we also need to prepare padding. So in this way, we can calculate it easily. Yeah. So now let's just do it like this. So for the prefix array and the suffix array, we're going to prepare some padding. It's going to be 0 plus the prefix array and plus 0. And similarly for the suffix array, we're going to use the same idea to use the padding. Yeah, because the padding can make the problem really easy for us to use the prefix and the suffix sum. Now let's just check what is the prefix and what is the suffix. Yeah. Now as we can see, for the first example, this is 0, 12, 13, and 0, because 0 is just the padding. And for the second one, this is the suffix array. It's 0, 9, 13, and 0. Now we can calculate it easily. So for example, we're gonna calculate the first number. For example, the first number gonna be 12. So what's gonna happen for this 12? So of course, from the left side, this is 0. And what about the right side? The right side is inside the suffix array, which is 9. Yeah. So this is 9. So this first place is I. So the next place is going to be I plus 2, because I plus 2 is 9. So 0 or 9, it is 9. And then what are we going to use? We're going to use this number 12. 12 is our first number. So we're going to use this number 12. Gonna left shift 1. It's going to be 12. Yeah. So 12. So this is going to be the first calculation. So 12 shift left 1 bit, it's going to be 24. 24 or 9, it's going to be 25, but it is not the largest. Now we're going to check the next one. We're going to check this number. We're going to check this 12. Yeah. So yeah. So for let me just think about it. Yeah, so for this 12, so this is the prefix sum. It is 12. Yeah. And what about the next number? It is this 0. This is the suffix array. But we need to use this 9. So this 9 gonna be left shift 1 bit, it's gonna be 18. So 12 or 18 is gonna be 30. This is gonna be the maximum. Yeah. Let's just use this idea to calculate it. Yeah. So I mean, this is the basic idea to calculate the prefix and the suffix array. And if you don't understand it, just check the drawing. I think the drawing just make it really clear. This is the left side, and this is the right side, and this is number, and this number just need to shift left k bit. Yeah, and then we're gonna use the bit OR operation to get the final result. Now let's just calculate the result. So the result gonna be 0 for I in range n. The result gonna be the maximum of the prefix I XOR suffix is gonna be I plus 2. Because we used the padding 0 left and 0 right side, so this means I plus 2 is still inside the range for the suffix array. Yeah. And we still need another OR, so this OR gonna be this number. So it's gonna be nums I left shift k. Finally, we're gonna return this result. Now let me just run it to have a rough check. I did something wrong. Int object is not iterable. Yeah, let me check if I did something wrong. Yeah, because I didn't use the result, it's gonna be the maximum of the result with this XOR. So the prefix sum and the suffix sum and our number is gonna be left shift k bits. Yeah, now as you can see, it works. Yeah. Now let me just submit it. Yeah, as you can see, it works and it's pretty fast, and the time complexity is ON. Yeah, because we use the prefix and the suffix to solve the problem. So I think the difficult part is that we need to use a greedy idea to find. If we want to solve this problem in ON time, we must use the greedy idea to find that we just need to shift one number instead of 2 numbers or 3 numbers. So inside the nums array, we just need to shift one number. If we are going to shift one number, so we're going to use the prefix and suffix sum to solve the problem. So I think that's all about it. Thank you for watching. See you next time.